salt of carboxylic acid. Okay, so carboxylic acid, salt, and that is in chapter 1. Then you want to name chapter 21 on derivatives of carboxylic acid. So amides, esters, acid halides, it's called, they're called anhydrides. This is not really, strictly speaking, a derivative of carboxylic acid, but they lump it in nitrile. So there'll be one of each of these to name. One carboxylic acid, one salt carboxylic acid, and one of these amides, esters, acid halides, anhydrides, and nitrile. So just be able to name those classes of compounds.
The salt of the carboxylic acid, don't you just name that like an ester?
Yes, you do.
Okay.
Then there's only one mechanism. That's from chapter 20, 21. So make sure you know the mechanism. I'm going to be looking for one of these guys here is going to leave and replace with one of the other guys. Okay. So for instance, if you have I don't know, acid halide. Write that mechanism. It's got to be 2 steps, and it's got to be 2 arrows in each step. So I'll be looking for 4 arrows, 2 arrows in the first step, and 2 arrows in the second step.
2 in each step.
Remember, arrows always originate from electrons. So, first step, we attack this carbon, and one of these first electrons goes on the oxygen. So that'll be the first step. And after the attack, what the substance looks like this. The second step is you reform the double bond, kicks out the chlorine, and you get the product. Okay, so be sure to do it 2 steps, 2 arrows in the first step, and 2 arrows in the second step. And that's how you kind of interchange these groups with each other. Some are easy to interchange, some are not so easy. This particular one here is a very easy one to do in the lab. Okay, accessibility mechanism. Substitution. Substitute for chlorine and OR. Alright, so we got naming one of each of these guys. We got this mechanism. Acid strength, since chapter 20 deals with carboxylic acids. Just remember, for this, be an acid, it has to lose a proton. if this is stable, it can lose a proton. See, the negative charge can be stabilized. So anything that stabilizes this negative charge makes the neutral carboxylic acid a stronger acid. Anything that destabilizes makes it a weaker acid. Right? So you can stabilize a negative charge or a positive charge by spreading it out or minimizing it. And you destabilize a charge by intensifying the charge or concentrating. So groups that are known to suck electrons away, like the cyano group, the halogen, the nitro group, sulfate group, these tend to pull electrons toward them and away from this negative charge. So if you have any of those groups on the R, attached to the R, it's going to make that carboxylic acid a stronger carboxylic acid. It's going to make it easier to form the negative ion. Okay. On the other hand, if you have groups on R that push electrons in, like R groups, more R groups, or OH group, or NH2, or NH2. You have these kind of groups here. They tend to shove electron density away from them toward some other location. And these groups here would tend to intensify that negative charge, make it not easy to form. And so the groups on the right here, if you see any of these, they make it weaker acid. These groups on the left makes it stronger. So now obviously if you see one of these and one of these, the effects kind of cancel each other out. See? But if you have just one of these guys, tell me it would be a strong acid. If you have just one of these guys, it would be a weak carboxylic acid. So a couple of questions on that. Okay. Now there won't be any resonance structures. I'm not going to draw resonance structures in this test. So and I don't think there's any homework. So we got naming, we got mechanism, we got acid strengths. In your book, in chapter 19, but I said we weren't going to cover it for the final exam. But in chapter 19, section 7 is on page 883. They show you how to take an organic base like this and a neutral compound and separate these two from each other. They're together, they're usually solid, and you want to separate them. So you go through a scheme for separating. That's in chapter 19 on amines. Then in chapter 20, under carboxylic acids, they go over how to separate a carboxylic acid from a neutral material, and that is on page 948. What they have is a carboxylic acid and a neutral compound, and these are together. You want to separate these in two separate piles, carboxylic acid pile and a neutral pile. So in the final exam, you're going to have everything together. You're going to have an amine, which is organic base. You're going to have carboxylic acid, and you're going to have a neutral. These three solids all together, and somehow you have to be able to come up with this. I'll have a scheme, a flow chart. If you just fill in the flow chart, how do you get three separate piles? So that's, make sure you can separate all three. And the first thing you do is you take this three solid materials that are all mixed together and dissolve them in some organic solvent. They're neutral, so they dissolve in an organic solvent. Okay. And then you're going to pull out either the acid or the base. Okay. So depending on which flow chart I give you, you've got to follow the flow chart I give you. My flow chart might have you pull out the acid first and the base second. Or it might have you pull out the base first and the acid second. Okay, but understand the concept. You got to pull them out one at a time. What you never pull out of your organic solvent is the neutral. The RH is neutral. It can't be made charged, so it stays in your organic solvent. But you can pull out the organic acid by making it charged. You can pull out the organic base by making it charged. And then neutral just stays in the solvent, and at the end you just evaporate the solvent and you get your neutral organic solid back in pure form. Okay. So just be able to do that. I'll have a flow chart and I'll have steps that you have to follow to separate these from each other. And just keep in mind, this being made charged, this is an organic base. So if I add HCl to this, now it becomes charged. And now it moves into the water layer. You see, here it's in the organic layer. Organic solvent. So I can take it out of the organic solvent by shaking it, extract it with aqueous HCl. That makes it charged. And then again, it goes back out of solution. I can take it out of the water layer by neutralizing sodium hydroxide, and I get this back again. This drops out of the aqueous layer. This is soluble in aqueous layer, and this will not be. So, and pull out the organic acid. It's neutral here. It stays in the solvent. I can make this charged by adding aqueous NaOH. That makes this charged. Here it is. And now it goes into the water layer. See, now it migrates into the water layer. Then I want to get it out of the water layer. So now I'll neutralize this with HCl. That makes it neutral. Now it drops out of the water layer. So that's the whole idea. You get it out of your organic solvent into the aqueous layer by itself, and then you then you drop it out of the aqueous layer by neutralizing it. So if these organic compounds are large, if they're charged, it can be made charged, they'll dissolve in the water layer. When they're neutral, they dissolve in the organic layer. All right, so you'll see something like that. Just review those pages, and hopefully it's not too different. I'll have the flow chart, and at the very end of each flow chart, I'll have these guys all by themselves. So you just have to figure out how do I go from here to here. So those steps. How do I go from here to here? So they're all together at the beginning, and then you end up with 3 separate products. All right, so just like you did in the lab last semester when you did extraction experiments, and sometimes this semester too. Anytime you use a separatory funnel, you were doing extraction. You had 2 layers, aqueous layer, organic layer. Some of the materials went into the aqueous layer, some went into the organic. All right, let's see what else. We got that. I think that's it. Now, since this is you guys are experts now. They won't be that difficult, but you'll have a few reactions where I give you, the starting material. And your reagent. And you got to figure out what the product is. Some of these questions look like this.
Instead of the page, you said 883.
948.
Some of the questions look like this. I give you the starting material, I give you the reagent, and you tell me what the product is going to be. And then some will be like this, and these are more difficult. I give you the product we wish to make,